we're now going to take a look at rhombuses and kites. And one thing we want you to remember about this is that the diagonals of a rhombus or a kite are perpendicular, right? Meaning that they cross at 90-degree angles. And that the diagonals of a rhombus actually bisect each other, okay? So again, that kind of creates, I guess, 4 congruent triangles, if we want to think of it like that. Okay, so let's take a look at this area formula, right? So the area of a rhombus and a kite is actually going to be the same formula, okay? So this is something that you either have to memorize or know how to derive, okay? I don't really care which one it is, but I'll definitely show you how to derive it. So it says that the area of a rhombus or a kite with diagonals D1 and D2 are going to be the area equals 1/2 times diagonal 1 times diagonal 2. Okay, so again, diagonal 1 here is just going from one vertex. It's going to skip one consecutive vertex and go all the way to the opposite one. Okay, and the second diagonal here would be from this vertex, again, skip one vertex and go to the opposite one. So that would be diagonal 2. Okay, obviously it's going to be the same thing. Diagonal 1 in the kite here, and diagonal 2 is right here. It doesn't matter which one we label as diagonal 1 or diagonal 2, but one thing we have to remember is that all of these are perpendicular, right? They're right angles, and that all of these are perpendicular, or they're 90-degree angles. Okay, so I'm going to go down here and take a look, and let's maybe look at how we might derive this particular formula. Okay, so I'm going to do a little bit of erasing up here so I can look at my picture and maybe make it similar. Okay, I'm going to go ahead and grab a dotted line, might be helpful. I don't want an arrow at the end. Okay, and so I'm going to call this is going to be one of my diagonals. This will be my other diagonal. Okay, and now I'm just going to call this, this is D1, okay, and I'll call this D2 as diagonal 2. Okay. Now the first thing that we would want to do maybe to sort of do this little proof might be to show that this is a right angle. Okay. To show that these actually bisect each other, right? So it's actually going to be the same length. Okay. And let's see, anything else we want to show? Maybe not. Okay. So let's do this. Okay. I'm going to show a little proof here where I'm just going to find maybe this green triangle. Okay, and so all I'm going to do here is maybe say the area of this green triangle is going to be equal to, well, it's going to be basically 1/2 multiplied by the base of the triangle, which is diagonal 1, times just this, like half of diagonal 2, right? So times half of diagonal 2. Okay. Oops, I forgot the diagonal 2 part there. So again, multiplied by half of diagonal 2. Okay, so all this really is here is 1/2 times base times height, where our base is diagonal 1 and our height is half of diagonal 2. So if we multiply this together, we basically end up finding 1/2 times 1/2 is 1/4, and then we multiply that by diagonal 1 times diagonal 2. Okay, well the area of the entire thing, okay, well I'm going to call it the area of the rhombus, is going to be equal to twice that, right? So again, we'll take the green triangle, and if we double that, that's going to give us the area of the rhombus, right? So if we double the area that we just got, and we multiply it together here, we'll actually find out that it's going to be equal to 1/2 times diagonal 1 times diagonal 2. Okay, so pretty much what we just did there is we just derived the formula for the area of a rhombus or a kite. Okay, so it's 1/2 times D1 times D2. All right, so let's maybe just take a look at one simple example. So this first one says we're supposed to find diagonal 2 of a kite in which the diagonal 1 is 14 inches and the area is 238 square inches. Okay, so I'm gonna try to grab a tool here and draw a kite. So let me see what I can find here in my tools. I'll just take a rhombus here. That'll be good enough. Okay, and so I'll take this particular picture. Okay, if I want to dress it up a little bit, just take some diagonal 1, diagonal 2. We can definitely do that. Okay, to show those. Okay, again, I'll say that the diagonal 1 here is 14 inches, so I'll call this 14 inches. Okay, diagonal 2, I'm just going to call this, we can just call it D2. Okay, and then the area equals 238 square inches. Okay, well, remember that the area of a kite is going to be equal to 1/2 times diagonal 1 times diagonal 2. Okay, and so the area here is 238 square inches. Okay, that's going to be equal to 1/2 that's in our formula. Diagonal 1 is 14, and diagonal 2 I'm just going to write down like this. Okay, I know that half of 14 is 7, so 7 times diagonal 2 is going to be the same thing as 238. And if I divide both sides by 7, I should find the length of my second diagonal. Okay, so I'm going to go to my calculator here, and I'm going to take 238 and divide that by 7. Okay, and that gives me 34. So I get now 34, and let's look at my units are. My units are inches. So 34 inches will be my length of my second diagonal. Okay, in the next video, we'll go through a couple more examples.